Thank you, Chris. And it's a pleasure to be here. I'll say that I'm not sort of a services expert, so I'm going to be speaking more from the perspective of a technologist, particularly somebody who's been kind of quite involved with the Internet of Things and trying to put a few pieces together over the next few minutes. Just before I get started, I have to put in the compulsory advertisement for New Venture Partners, the firm I'm with. We're a venture capital firm, legally and financially. We look like all the VCs, just like the guys you see on Shark Tank. The key difference is that we specialize in spin-outs from corporates. So our experience of many of us is that often things get invented in the wrong place. Essentially, you get projects in corporate R&D that get stuck because the business unit isn't ready to take them, or perhaps the company's strategy changes along the way. And now there really is no natural home for the project within the company. So we negotiate, work with the companies to spin those projects out. The company ends up being a stakeholder. We invest, find co-investors, and turn it into a new startup, a spin-out company that can take the project forward and often achieve the strategic results that the company wanted to achieve in the first place, particularly if the project was involved in building your ecosystem, et cetera. So I mention that since I realize that a lot of the audience here today are corporate, and some of you may occasionally be faced with this challenge, as I was and many of my colleagues at Intel. So today I'm going to really focus my remarks on sort of the boundary between big data and the Internet of Things, with more of a focus on the Internet of Things and particularly the services aspect. The first thing I want to make clear is I'm just phenomenally optimistic about the opportunities that we collectively have, particularly on this boundary between Internet of Things and services and big data, right where these triangulate, to have enormous impact economically and on quality of life and on productivity. And it just, touches pretty much all of these different domains. And I think these are things, SRII mentioned my work at Intel. I think we identified early on at Intel, and I continue to be, not only optimistic about this, but we can actually now see it happening. These are all domains in which I'm sure many of you in the audience are involved in a day-to-day basis making a difference. So today I'm just going to touch on three things. One is sort of, for me at least, some personal history about my own research interests, which have been sort of trying to move at least a portion of this computer science research community from interactive computing to something we call proactive computing. So it's a bit of a retrospective, and then talk about the Internet of Things and trying to bridge that, particularly to the topic of this conference, something I'll refer to for a moment, for at least this morning, as Things as a Service. It doesn't exactly roll off the tongue, but good a title as any. And then bridge that to some economic observations. So, in terms of proactive computing, it's worth kind of going back to the history of computing. If you go back to the 50s and the times when we first started using computers, or stored program computers in particular, it was really just to do numerical computing. We were crunching numbers. We weren't even processing symbols. So it was primarily to perform computations, solve equations, et cetera. In the 60s, as we moved from numeric computing to symbolic computing, now you were doing payroll and things, processing text, people started to realize that there could be a life beyond batch computing, and the vision of interactive computing was formed pretty much in the late 60s, and that's something that was really pushed very aggressively by DARPA, initially through time sharing, but always with a view to get us to the sort of personal computing world that finally took off in the 90s, when we really sort of get to the point of a computer for every person. So it made sense that in the 90s we had to start thinking about what came next, and that's something that we actively did at DARPA and at Intel, and particularly start thinking about what happens when we don't just have a computer per person, but we have tens, hundreds, thousands of computers per person. And The challenge that we face with interactive computing, the paradigm that the research community had followed for many years, is it was deliberately human-centered. In many ways, it followed the Apple paradigm. For those of you that have looked carefully at Apple over the years, they very much believe in a human-centered interface. Your Mac shouldn't do anything unless you push a button or touch something or now say something. But it should always be only responding to interactions with you, so it's very human-centered. And human-centered computing is a good thing, so we shouldn't leave that behind. It's good to put the human at the center of the world. And yet, at the same time, we can overtax the human. If you're going to have thousands of computers, you don't want to be interacting with thousands of computers per person. And perhaps if you're an enterprise operating millions or tens of millions of Internet of Things style sensor nodes, et cetera, you certainly don't want to be managing all of them individually on a human-to-human basis, machine-to-human basis. So it was definitely time in the late 90s to start thinking about computers that didn't need to interact with humans, and in fact, to go a step beyond that, computers that were proactive. Not only would they not be waiting for our instructions, but they would actually be trying to anticipate our needs and sometimes acting on our behalf. And a huge body of research was set off with a lot of researchers working on that, while other researchers continued, by the way, to work on interactive computing because we still had a lot of work to do there. So we sort of launched a second front. And today I think we've seen a tremendous amount of progress on both of these fronts, and I'm not going to take you this morning through all of the detailed accomplishments. But one of the things that has amazed me, if I sort of look at this, sort of 10, 20 years later, is just how much additional progress has been made on making computers even more interactive than they were. So it's not as if interactive or human-centered computing has gone away. In fact, it's gotten deeper and better. Most of these were in areas that had been anticipated really since the 60s. So the surprise is that it's finally happened, not so much that that these were possible or that people were working on them. But we've seen, particularly in the past few years, a tremendous spurt of innovation on user interface. And that's something that we really hadn't seen since the late 70s. In the late 70s, the sort of Windows mouse sort of paradigm, what you see is what you get, had been developed in the research community. And from then on, it was sort of rolling that out through the 90s to being used broadly by the public. And we had very little new change in user interface. Now we have sensing, we have inference, we have multi-touch, we have mobility. You're seeing speech finally roll out on a mass basis. It's been available for a number of years, but now it's really being used on an individual basis. So tremendous progress in driving interactive computing even further forward. And I think particularly the issues of mobility, the having kind of high-speed wireless data at your fingertips is going to make the biggest difference. And the progress in interactive computing is actually essential to the Internet of Things and to the progress on proactive computing, because that sort of gives you your wireless handset, gives you your kind of command center to actually provide the commands. Even in this proactive computing world, you're still going to want an ability to task these thousands of sensor nodes, et cetera, or to consume the data that's actually been processed from them. So the other thing that's happened, which I think has been sort of very pleasant surprise to me, things don't always turn out exactly the way you expect, is the way we've got this duality of mobile and cloud and the way they work together. And the clouds are really becoming proactive. So in some ways, the information flows from that very large Internet of Things to the clouds. The cloud's a place where we can crunch on data, and this is the big data aspect of this morning. The cloud's the space where we can pull this information together, apply very large numbers of processors to it. We've learned with technologies like MapReduce and Hadoop and Diet and others how to allow programmers writing just very small numbers of lines of code to task thousands, tens of thousands of servers and do this as an everyday event. Just a few years ago, 10 years ago, that was an enormous challenge. Only a very small number of people were able to program large-scale multiprocessors. Now through sort of scale-out techniques and techniques like Hadoop MapReduce, it's a relatively straightforward everyday event, and that's what's really opened up the door to big data processing. So the clouds, through big data processing, now have that ability to be proactive because they can crunch through the information and they can start anticipating our needs, thinking about what we're going to want to do next. And we see this in a whole number of ways. This morning I saw this in a very significant way because I suddenly realized my talk was at 9:10, not at 9:30. And fortunately, Google had been out there crunching the traffic patterns for me in advance. And it wasn't just Google because, of course, they get their information from the highway system. So there's an enormous number of sensors, including all of our cars, all the cars driving on the road that have FastPass on them, are feeding information into it. It's being crunched. It's not quite real time, which is still a little disappointing, but it's close to real time. And out comes some good traffic advice. So if all that information processing hadn't been done before I asked the question, if it hadn't been done proactively in anticipation that somebody might want to know how to get from north on the peninsula to the hotel here today, it wouldn't have been possible to do it. So the cloud has definitely become sort of an interesting tool in enabling proactive computing. There's definitely still a number of other things you need. So if we're going to have computers that are anticipating our needs and sometimes even taking advanced actions on our behalf, there's a number of things that we need. Some of them we've now got. Again, as I said, the research community's made huge progress. This has been sort of an organized effort. We've got the machine-to-machine communication on a planetary scale. That's a big deal. It doesn't feel like a big deal. As soon as something is done, we no longer give ourselves credit for it, right? We just it becomes an everyday event. Ubiquitous data collection and aggregation isn't really fully out there yet. We don't have sort of all the devices out there. We haven't fully instrumented the physical world. But if you really want big data in a significant way, if you really want to see proactive computing, it really comes down to get the data and crunch on it, right? So to get the data, you've got to go out and instrument the physical world, bring data in, and you also have to deal with the uncertainty in the data. So we have gotten very good in the research community at this data collection and aggregation. We know how to do it. You see through the advent of the machine learning work, particularly this type of machine learning used in big data, it's very heavily statistically based. It's good at dealing with uncertainty, it's good at dealing with the noise in the information it's getting. So I put a check mark by that one because we know how to do it. We haven't completely done it because there's still a lot of the world that we need to instrument. But from a research perspective, I think it's in good shape. We still need to get better at doing this data fusion and inference in real time. So that's sort of one of my requests to the big data folks, given this is a big data morning here, is let's start moving big data processing into real time. We're good at doing the fusion and inferencing. We know how to do it. In most places, we're not fully doing it in the sort of online loop. And I'd really like to see us get better at doing that. And then finally, a place where I think we still need some research. There is research going on, but I'll admit we don't fully know how to do it, is if we're going to have these computers sometimes taking actions on our behalf, we've got to get much better at autonomous operation, and that means closing feedback loops. And there's been quite a bit of research over the past 15, 20 years on software-enabled control. For those of you that sort of have engineering degrees, you probably took at least some rudimentary control systems. But probably all of that was done in the assumption of a physical control loop, and a control loop that had a fixed time delay. If you think about it, when we start running control systems over packet-based networks and over software-based systems, the delay is varying. A lot of what you think of in control theory has to change. And then if you start thinking about having large numbers of interacting control loops, we still have a lot to learn. Now, part of the reason I think of this closing the loop, how do we kind of close the feedback loop and do so in a controlled way is important, really comes down to this business of tasking. If individuals are going to be able to task very large numbers of computers, it's probably going to be through essentially agent-based systems. Again, an area where we've had lots of good research results over the years, and an area where agents are sort of being rolled out and used in many ways without us really thinking of them as agents. So just as a kind of a question, how many of you use Google Alerts? Right, a fair number. Well, so you've got agents working for you, right? That's a form of agent. And when we, have things spotting watching our eBay auctions for us, when we have any number of systems spotting airline fares going up and down and giving us alerts, et cetera. So we're already using agents in a pretty serious way to task computers to do things for us and to be sometimes, in some cases, acting on our behalf, not just spotting, telling us something's happened, but taking some action. That happens on eBay, in fact, when you set up auto bidding. So in some ways, the limiting resource is how quickly and how easily we can task agents. If we want to have thousands or millions of agents each working for us, we have to get very good at tasking these agents, and they have to get very good at closing the loop autonomously. So I just want to hang that out there as a research challenge. Lots of work's been done, but we're still not really there. So to move to sort of the next segment of the talk, that's kind of the proactive computing update. One of the things that we've been struggling with now at New Venture Partners with our startup companies, and we noticed a lot of other startup companies struggling with it, is let's say your company has some kind of widget that's going to instrument the physical world, so it's going to get out there and help us instrument the world or help us obtain information from the physical world. When you actually go to sell that to people, the challenge that your customers have, particularly your enterprise customers, is how do they deploy and manage very large numbers of these edge devices? Because a large enterprise might be looking at having millions, tens of millions, hundreds of millions, or even billions of these devices. And you're this small little startup company with this new innovation. You're trying to sell this to the enterprise. The first thing they want to do is some kind of pilot, and then they're going to do a slow rollout, et cetera. So you have actually quite large barriers to entry. And I'd say it's not just a function of it being a startup selling it, it's really if anybody's trying to sell one of these new types of capabilities. And if you think about it, you could argue that this problem occurs to anybody trying to sell something new to enterprises, but it's particularly an issue if you're trying to sell a large number of devices that are going to be deployed all over the place. Right? Because if you think about it, each of those devices today, when it's deployed, it's got to be drop shipped somewhere, it's going to have to be brought on the network, and that's a key thing, it's going to have to be integrated into the sort of local area network. It's probably going to have to be integrated into local software control, local management software, and then it's going to have to somehow tunnel through probably to some core enterprise software that's actually intending to consume the data. So it's going to go through many layers of networking and software, and each one of these devices has to do this. And while you're rolling this out, all of those different components are being changed by various people within the CIO's office. So the network configurations keep changing in the enterprise, the software configurations, the software versions, et cetera. So it gets pretty painful to be doing this, especially for devices that are supposed to only cost maybe a few dollars per device. Very quickly, just the cost of deploying and integrating these devices exceeds their overall value. And one of the things that's been interesting is to see how multiple of our companies, and I suspect many startups now, I just haven't taken an inventory, are realizing that a better, faster path for them is to not just sell the device, but to actually provide the service and the network service and the capability to exfiltrate the information from the devices, and then exchange the information with the enterprise on a cloud-to-cloud basis. So instead of just giving these devices to the enterprise and saying, you figure out how to integrate them into your environment, even for a little startup, it's today economic for the startup to essentially say, we'll get them out there and deployed, we will consume the information, we'll worry about the connectivity, we'll worry about exfiltrating the information from the devices, we'll do the initial processing of it in the cloud, probably using something like the Amazon Elastic Cloud or a competing service. And then the only thing that we'll really have to do, the enterprise will have to do to get the data, is integrate on essentially a cloud-to-cloud basis. which just means take another XML feed, which people pretty much know how to do today. That's a kind of a no-brainer for most enterprise shops. So I just want to walk you through some examples of companies that have done this. We've got kind of 2 of our own portfolio and 1 other from another colleague. And as I said, I suspect there's a very large number of these out there. And if you think about it, this is basically, I think the people that sort of did this, I'm not sure they did it first, but they did it most publicly is when Amazon rolled out the Kindle and provided a network service with it. Now the difference was the Kindle was a relatively high price tag item, a couple $100. Now you're talking about people being able to do this and doing it with very small items. So here's one example from our company Alverix. So Alverix makes and I think Alverix was here last night, or they were planning to be here. I don't know if they made it to the demo showcase last night. And their challenge is that they make a reader for point-of-care diagnostics. So if you take your kid to the doctor's office, the doctor will give them, or can give them today, a flu test or a strep test. Now, historically, if the doctor was equipped to do a point-of-care test, when they did that test, it was human read, so it was like reading a pregnancy strip. Most of us who have kids have memories of reading those pregnancy strips. Is it plus? Is it minus? Don't know. Wife didn't know. Go buy another one. It's actually a structure that works very well for the pharmacies because they usually sell each person, multiple kits. People buy a few of them until they find one that they can read. So the bottom line is there's a lot of error in the human reading of these point-of-care tests, certainly to the point where the doctors get nervous about prescribing drugs based on them. So Alverix has a very low-cost handheld reader that can be used for these tests. So you get basically the same results you would get if you send it to the lab, but you now get them in the doctor's office. The problem is that you need to integrate that reader. So you've got the reader, you've got the data now, right? It's been read by sitting in a computer on this little handheld device, and you need to get that information into the lab or hospital information system. And if you directly try to connect it, so the obvious thing is, well, we'll just put a USB connector or an Ethernet connector on the device, and we'll just plug it in and away you go. But now everybody that gets this device, every doctor's office is going to have to figure out how to configure it and integrate it and get it working, not just on their network, but all the way up through the stack, say to get it to the Kaiser database or even to the insurer's database, et cetera. So although it's not intuitively obvious, the simple way, best way that we have found to do this is instead equip each of these devices with its own cell phone modem, exfiltrate the information through the cellular system to our own HIPAA-compliant data center, process the information there, and then just do the XML to XML exchange. Huge reduction in the barrier to entry, the configuration time, et cetera. Now you can get lots of these devices to a very large number of places. Notice that all the devices look identical to us. We don't have to do any special configuration because they're all essentially connecting in the same way to the same place. Munisense, a company in Europe, has come across a similar thing. They do air quality monitoring for municipalities, so municipal sensing. And I'm using the diagrams from the various companies. I've simplified them a little bit. So in their case, they've actually inverted whether it's over the top or tunneling through the bottom. In their case, they're tunneling through the bottom. But same basically idea. You want to get the data from the sensors to the end users, and also allow the end users to control the sensors to some degree. But it's a lot easier to go through the cloud than it is to do it directly. So they've arrived at the same solution. IntelliFlex, which I believe is going to be demonstrating tonight at the demo showcase, has come up with independently the same basic approach, things as a service, where their product is RFID tags and RFID readers. But if you want to go equip every warehouse, every distribution center in an enterprise with RFID because you want to use it in your supply chain, and by the way, the value proposition is very well proven, you have to deploy RFID readers through all these different places. And each of those places has a slightly different network configuration, different stack, et cetera. So again, you get into a very long deployment cycle. IntelliFlex is now starting to offer its Zest service where essentially, again, they will equip the RFID reader with a cell modem, exfiltrate the information to their own cloud, do cloud-to-cloud integration. So these are all ways, I think, that by having even small startups now think of data, instrumented sensor data as a service, they not only can provide value adds, obviously each of these companies is also thinking about how much extra value they can get from the data, all the extra things they can do for their customers, et cetera, new revenue sources. You know, they all have that glimmer in their eye about it, but to me the interesting thing is that just, you know, on a sort of simple reducing barriers to deployment basis, this approach seems to be heavily validated. The other thing that I want to point out sort of in passing is, in addition to sort of lowering the barriers to entry, notice that all these devices are connecting through the cell phone system, as are sort of, you know, most of our wireless devices are, you know, our phones, our tablets, et cetera. And, you know, one of the questions this raises for those of you that are kind of networking folks, CIO folks, within different communities, maybe, you know, what this does in terms of the end of the role of the LAN, because local area networks are getting used less and less as the data essentially just goes everywhere into the cloud and then across cloud to cloud. But I just wanted to now sort of put this whole thing in a bigger context in terms of not just big data, but particularly since this is an SRII conference, a very interesting essay I read on the second economy by Brian Arthur. Brian Arthur, many of you may know, is written, you may or may not recognize his name, but you probably know of his work. He's written a lot about technology and economics, particularly, I think he was the one to first sort of codify the notion of increasing returns to scale. So why ecosystems like Intel's and Microsoft's and others have done so well, and really putting that into economic terms. And Brian's really been digging in on this whole issue of what happens as we start automating processes. So part of my message here is I think a lot of the world on the outside thinks of the service economy as being sort of people, individual people providing services, very labor-intensive, people-driven process. But as we instrument the world around us and we get better and better at that autonomous operation I talked about earlier, these processes are more and more getting automated. And Brian's observation basically is that increasingly a huge fraction of our economy is actually disappearing into not just the services space, but this second economy, this sort of unseen, automated, autonomously operating economy of computers that are all talking to each other, sensors in the cloud as I described, proactive processing, and essentially, you know, what he calls the vast, silent, connected, unseen, and autonomous build-out. And really with no limits in sight as to how big that second economy might get. And I'd really encourage some of you to take a look. It's a fairly short essay Brian's written on this, and I think it has a lot of implications for this services community.